All right, I'm back with more AP Pre-Cal Homework 9-1 solutions, more arc trig. All right, so on number 6, write both solutions to the equation from 0 to 2 pi using the inverse. And it's got a little example here. I'm going to, I think, because I'm the one here to explain this to you, I'm going to just like kind of work it and not really work the example. Draw some diagrams and stuff. If you are looking for like the beginning of AP Pre-Cal Homework 9-1, maybe right now you could click up here and I'll make sure to remember to put one of those things so that you can click and be taken to that other video. All right, so let's get to it. 2 plus 5 cosine x equals 6. Write both solutions on 0 to 2 pi using the inverse. Okay, so I'm going to just start solving for cosine, and then I'll use inverse cosine. That's what we're talking about here. So subtract 2 from both sides. I can work in blue. 5 cosine x equals 6 minus 2 is 4. Okay, then I'll have divide both sides by 5. Cosine x equals 4 divided by 5, which is 0.8. Okay, but as long as it's between -1 and 1, we can take inverse cosine of it because that's a potential output value for cosine. Not going to be on the unit circle though, and that's the whole point of this set of problems right here on this page, is that these are not unit circle values. So we're going for an exact value, which will just be arc cosine of 4/5. All right, so x in this case, when I take arc cosine of both sides, is going to be arc cosine of 4 divided by 5. Okay, now I'm going to, because we have to think about, are we adding pi, are we subtracting 2 pi, like what's going on here? I'm going to just draw the diagram for you. All goes back to the idea of the circle. Just like pretty much everything we've done in this class since we've started in on trig. And we've got this here, that there, sure, that works. Our cosine takes its values on this range of the circle. But we're interested in where cosine is equaling 4/5. So I would say, all right, that would be, I'm saying maybe about right there. Oh, whoops, look very above. I'd say about right there. Okay, but then there's also this other point down here, and that's what I'm mainly interested in. So that right here is what I would say is like the amount of theta is the arc whose cosine is 4/5. That's why we call it arc cosine. I'm realizing I'm definitely, my area is covering that up. Okay, and so that's arc cosine of 4/5. That's one of the solutions. But then there's this other solution, which I might color in green down here. It's the other place on the unit circle. That's what it's saying. The two solutions on the interval 0 to 2 pi where this is happening. Okay, so arc cosine of 4/5 is a positive number. It's that amount of angle. So, and that's how much we went, to you. Yeah, it would be that way, counterclockwise, positively. And this other angle looks like it's the same distance clockwisely. So it's going to be the negative. Okay, and I think that's how I would, oh no, but it said on the interval 0 to 2 pi, so it would be 2 pi minus that angle. Okay, I get I don't think I was totally understanding the nature of the problem until just now. Arc cosine of 4/5, after we are subtracting that from 2 pi, so I'm going to need to move that off to the side and say, all right, yeah, I'm interested, interested in x equals 2 pi minus this number. Okay, and that would be the other solution on the unit circle. All right, yeah, I think it's definitely good to draw a diagram for these, and I can't be too careful. So I'm going to solve for sine x first. That's sine x equaling 1/10. And now that I've got it just kind of like before, I'm going to draw the circle first. Once you get it down to trig function equals number, we can proceed. It's just, these are not numbers we're used to on the unit circle, so we're not going to be able to draw a reference triangle and figure it out like we tried to in the last unit. That's really the difference here, is that we're just no longer on the special right triangles necessarily. So sine x equals 1/10. Well, remember, sine takes its value, or arc sine takes its values through here, and I neglected to actually solve this equation. I think I was still in that previous unit mindset where it's like, okay, trig function equals number, go to the unit circle. You can. We can look for places where sine x equals 1/10, and I might actually start right here and say, all right, that's really not very high up. So there's one place, but then there's going to be another one right there. Okay, that's the other one that I'm talking about. It's not on the colored portion. So sine x equals 1/10. That means x equals arc sine of 1 over 10. And, okay, this is also looking like, okay, above there, that looks like pi minus arc sine of 1 over 10. Yeah, because that's going to be a positive number. So it's going to be x equals 1 pi minus arc sine or inverse sine of 1 over 10. And we could, pull out a graphing calculator or something and figure out the decimal value of inverse sine of 1/10, but it would just be some number of radians. It wouldn't mean all that much to us. And then we'd take pi and subtract that decimal number, and then it goes yet another decimal number of radians that wouldn't have that much meaning to us. So we're just going to stop here. That's all we need. And then -3 sine x equals 2. So I'm going to solve for sine x, and I think, hopefully, what was the actual example that we printed? It was a cosine. Okay, yeah, this will be perfect. Coming around to a point here. So sine x equals -2 over 3, once I do that. And then this time, I won't forget, I'll take an arc sine of both sides, and I'll have x equaling arc sine of -2 over 3. All right, and so I'm going to look at the circle. Okay, I'm just going to make sure to... Not bad. Arc sine takes its values on this section of the unit circle. Which, imagine I'm going to deliver this lesson, tomorrow, and I'm sure I will be really emphasizing that. Arc sine of -2/3. Find me the arc whose sine is -2/3. Okay, so the vertical displacement from the x-axis is -2/3. That would be down here. So this is going to be someplace right there-ish. And then there's going to be another place about there. And what was I thinking? Okay, so this is just like, that's my first value. I think I need to maybe make more use of color here. Okay, because that red dot, yeah, the last one was probably regrettable. The red dot is representing, that's the actual arc cosine or arc sine of -2/3. But there's another solution to the equation on the interval 0 to 2 pi. There's another place on the unit circle where sine is -2/3, and that's right there, that place I marked off in yellow. So I might say that this is, well, it's a negative number. Let me think about this. It's like pi plus the positive version of that angle. So since that number is negative, I guess it's going to be pi minus arc sine of -2/3. That is tricky, but I do think I like that because, okay, I'm going to say that's going to be pi, just regular pi, minus arc sine of -2/3. Yes, I like characterizing it like that. Okay, because arc sine is a negative value. Okay, arc sine of -2/3. Down here, this one right here, that's a negative amount of radians that I've rotated clockwise. Okay, because of just the conventional output range of arc sine. It's from -π/2 to π/2. Because that's a negative number, and I really want to be adding from pi that amount of arc to get down there to the yellow dot, it's going to be pi minus that negative number. Okay. And now I'm going to emphasize that with some yellow. Okay. But I am going to zoom out and look at the last time we looked at an arc sine. The second solution right here, which was, I'll use yellow for that, I think that's a little better, was again pi minus. Okay, now I don't think this is worth memorizing at all, okay, but since we did both of these, it does seem like when we're finding the other solution, when we're using like arc sine, the other solution will be pi minus the first one, okay, and then up here, if I was to look at the example versus this one, okay, the green number now, I have 2 pi minus, and once again, 2 pi minus, okay, so for arc cosine, it looks like that's how it's going to work. Okay, now we should, I was hoping that we'd have, oh yeah, here we go. We have a tangent one there. Find all solutions to the equation h of x equals 5 if h is the function given by tangent x. All right, so tangent x equals 5. And so that's not something we know from the unit circle, so x equals arctangent of 5. And what was I thinking about that? Oh, Okay, that's just someplace in the first quadrant, probably pretty close to pi over 2. Ooh, yeah, I had a feeling that was going to be an oval. That was so bad, I didn't even realize I wanted a circle. And, all right, so arctangent of 5, I think that's going to be, like, up there. Okay, but tangent has a period of pi. Okay, so, and we always saw solutions to a tangent type equation that sat across the circle from each other. So, I'm just going to say, find all solutions. It's going to be x equals arctangent of 5 plus pi times n, where n is an integer. Okay, now we're going to find all solutions to the equation h of x equals 5 if h of x is 15 cosine x. All right, you can't really see that, but there you go. I kind of wish it was h of x equals cosine x, because there is something that has not come up in this homework yet, and that's like arc cosine of 5. That doesn't exist, right? Because cosine's stuck between -1 and 1, so we can only take in values for arc cosine that are between -1 and 1. All right, so h was 15 cosine, right? Yeah. So 15 cosine x equals 5. Divide both sides by 15. Get 5 over 15 is 1/3. And, okay, so x is going to equal arc cosine of 1/3. Okay, that is... well, not great, but good enough. Okay, where is cosine equal to 1/3? About here. Okay, so that's there. That's my first solution. And so that would be, like plus 2 pi n, where n is an integer. But then there's also this other place right here, so that's going to be 2 pi minus arc cosine of 1/3. I'm not going to think about that too hard. Let me just make sure. Okay, cosine was, going back at 2 pi minus. Whew, I see there's something going on here, because like my other one, maybe I'll use a different color for, maybe I'll just highlighter it or something. That one right there, that's going to be x equals 2 pi minus arc cosine. Oh my goodness, no, it is a plus of 2 pi. What is going on here? Oh, it's negative. Oh, and yes. And I kept waiting for somebody to figure this out in my class last unit when we were solving trig equations. When you're solving a cosine equation, you can just throw a plus minus on it. Okay, I don't know if you ever thought about that. But this is positive and negative version of the arc cosine. Okay, so I've got 2 pi minus this, and now it's making a whole lot more sense. Why? It's like why am I having plus 2 pi n, and then another one where it's just like I could combine this in 2 pi times n plus 1, really, if I wanted to. I'm just going to leave this here. This is a general solution. I don't think we should be needing to do this. On the AP exam, the sample problem that they released that had you do this, it was a unit circle value, the one where you found the general solution. So I'm just going to leave that there and keep moving on. All right, find all solutions to the equation h of x equals 10 when h is 25 sine x. All right, happily. So 25 sine x equals 10, and divide both sides by 25, and so 10 over 25, 5, 10, 2 over 5, yeah. And all right, so x is going to equal arc sine of 2 over 5. Okay, thinking about where on the unit circle is sine going to equal 2/5. So 0.4, that's like almost all the way up to half. Right there, that's arc sine. Okay, but then there's that other place, right, that I'm looking for. Mark that one off in green and come back to that in a minute. Okay, so x equals arc sine of 2/5, that's the blue one, plus 2 pi n, any coterminal angle. But also I need to, kind of find the green angle. And so that's going to be pi minus arc sine of 2/5, because really what I'm doing with arc sine, just to take it back. I don't know if I've mentioned it in this half of the homework. But remember, arcsine gives us the amount of arc whose sine is 2/5. So it's an amount of angle. And so it's giving me this, amount of rotation on the unit circle, which is a positive amount here. And so I'm going to have subtracting that positive amount from pi. I think that was enough discussion. All right, so x equals pi minus arc sine of 2/5, possibly any angle that's coterminal to that, plus 2 pi n. Yeah, that's going to be plenty for us. All right, so now here we've got, yes, my favorite. And, I definitely do have a message here on this one, too. I hate this problem. I just really don't see the point here. Having three graphs on top of each other, especially in black and white, which is what you're going to be up against on the quiz. Oh, boy. Good luck, But what I think about it doesn't matter. Okay, who cares about my opinion? I'm just trying to give you a good, positive AP Pre-Cal experience, and that's going to involve preparing you for the exam. And we know that, this is the type of question they might ask you. So, y equals f of x, y equals f of 2x. So one of them got horizontally compressed by a factor of 2, and one of them got vertically dilated by a factor of 2. I said compressed. That was maybe the last year Algebra 2 in me. I should have said horizontally dilated by a factor of half. Okay. Crunched. So I think that means that definitely red is going to be the one, solid, that's the one that's been vertically dilated by a factor of 2, because it's the tallest. Okay, so I'm going to say solid, which is also red, that's going to be 2f of x. Okay, for the green dashed line, just going to grab that real quick. Okay, that one looks like that's the one that's been horizontally dilated by a factor of a half, because it's otherwise the same as the dotted line. And so I'm going to say that one's the one that's been having a horizontal dilation by a factor of a half. So that's where we replaced x with 2x. Okay, and then there's the dotted line, which is in black. Okay, and that's just going to be regular f of x. And now our job is to determine whether it's arc sine or arc cosine. And so I think, we need to just look right here at that spot right there, the origin. Okay, that's part of the graph. So is 0 equal to arc sine of 0, or is 0 arc cosine of 0? And I think this is a good question for me to ask you at this point. Okay, so remember, is 0 the angle that corresponds to sine equaling 0 or cosine equaling 0? Well, let's just go to theta equals 0 on the unit circle and figure it out for ourselves. Okay, that's theta equals 0 right there. Okay, what it would be 0, or like the coordinates of this point would be 1 and 0. What's 0 is the vertical distance from the x-axis, which means that sine of 0 is equal to 0. Okay, so that means that I'm looking at the graph of f of x equals arc sine x. Okay, and then here we've got 3 more, and all right, y equals f of x, y equals f of 2x, and y equals 2f of x. I'm going to use the same strategy. I'm going to look at the two that have kind of the same height, and I'm going to say they have to be horizontal dilations of each other. Okay, so I think dashed is going to be the original, right? Because we didn't actually, we didn't change really the structure of the question. Okay, so dashed is going to be the original. It's going to be f of x. And I know that this is going to be, it's either arc sine or arc cosine. I know it's going to be arc cosine, right? I just did the one that was arc sine. This is a different graph, so it must be the different function. But I'll, give you a better reason after that. Okay. Solid, which was green, was the horizontal dilation by a factor of 2. And then dotted, that's going to be 2f of x. I guess, yeah, that does look right. Okay, and then as far as which one it is, okay, so it looks like, all right, on the original graph, I'm going with, numbers I know for sure, grid intersection points. The only thing I can see, and this is, okay, dashed graph is not good because you lose part of the graph. It's going to go down here to this point. This is the one point on the grid that I know. And so I'm going to say it's got 1, 0 on the graph. So is arc sine of 1 equal to 0? No. Theta equals 0 is not the place on the unit circle where sine is equal to 1. Okay, so I think about arc cosine of 1. When I do that, I think about where is cosine theta equal to 1 on the unit circle. That is right over here at theta equals 0. So that would give me, okay, that's theta equals 0 right there happening. So this is indeed the graph of, dashed was f of x equals inverse cosine x. All right. Another one. Great. Okay, now arctangent, I would start with the horizontal asymptote. Ooh, that's a little tricky. Okay, the one that has twice the horizontal asymptote, that's going to be 2f of x. All right, so 2f of x, I think the horizontal dilation by a factor of a half is going to be the green line, so that's going to be f of 2x, and then the dotted line in black, that's just going to be regular f of x, and this is inverse tangent of x because you see the double horizontal asymptote. Okay, that's in my mind, that's the most defining characteristic of arctangent's graph, is that it kind of is somewhat S-shaped and that it has two horizontal asymptotes, because it has two limits as x approaches positive and negative infinity. All right, the graph of a sinusoidal function is given below. What is the length of the largest interval of input values on which an inverse can be constructed? I was waiting for these. Okay, this is kind of where we started our discussion of inverse trig, and so I was kind of like, where's the largest interval constructing an inverse question? Okay, I was expecting it's going to be on the quiz next time. So here we are. And I had to just check and make sure this is the last page of the homework. So we're getting there. We're almost done. Okay, so the graph of a sinusoidal function is given. What is the length? Okay, yeah. Okay, so that's going to be, I think the easiest thing is what Ms. Salas suggested to me, is to say maximum to minimum, or minimum to maximum. Okay, but really, without getting too much into the topology of the situation, function's going to be invertible on a domain if it's strictly increasing or strictly decreasing. Okay, we're not going to talk about injection, bijection, surjection in this class as much as I would love to. Oh man, that would just be the best if this was part of this course. It is not. And so I'm just saying, for inverse trig, on a function like this, or really on any function, we need, if we want to construct an inverse, the function has to be monotone increasing or monotone decreasing. I was going to leave it with that vocabulary. So that interval had width 1. Okay. Over here, max to min, same idea. That was from 1 to 3. That's a width of 2. Okay, I think you see the pattern here. Okay, these questions are very easy if you know what to do, but knowing what to do is pretty advanced mathematics here. Okay, this one, I don't really have, I guess I can see on the right side I've got that, but I can really clearly see I've got a minimum here and a maximum there, so I'm just going to measure from the minimum to the maximum. And that's going to be from -2 to 2. That is a width of 4. And then this last one, okay, cool, we got one in terms of pi or something. From the maximum to the minimum is going to be from 0 to pi over 4. It's like, yeah, we could choose some other interval, but that's the easiest one because it's going to be pretty easy to subtract 0 from something. All right, so that's a width of pi over 4. That is the length of the longest interval on which an interval can be constructed. That's going to be all for homework 9.1. Thanks for watching.